So, welcome everyone on board. My name is Azhar Nasir. Uh, Today I'll be giving a presentation of design of facade for multi-rise buildings. I'm principal of Safe Australia Consulting Engineers. We have abbreviated our company name as Safe Aus, and we operate in mostly in buildings, but in partly infrastructure as well. And slowly we are getting into the project management. So that's my brief intro, and my inspiration of talking on facade is some of recent projects in past couple of years we have delivered for one of our very prime client with whom we have got a DNC design and build type of agreement. Ambience, they are based in Sydney, and they have projects all around Australia. So in terms of SafeOz, our current areas of working are in facade design. That's where we have been kept busy for at least last couple of years. Low-rise flat apartment building design, industrial and institutional building design. So in terms of institutional, we have done stadium as well as places of worship. Residential building design and Green Magic Home. Green Magic Home is a product which we generally are delivering these days in joint venture with the lead architect from New Zealand, and builder has basically got a significant project delivered in USA. And we use our finite element capabilities in delivering these Green Magic Homes. Then we do a lot of public schools for demountable structures, and we have a partnership with an architect in terms of delivering these projects. Then a lot of retaining walls we do, stormwater management design, roof certifications for solar panel installations, and telecommunication tower certifications for antenna installation for TPG, Optus, and alike. Then in our normal day-to-day, we do site inspections, adequacy certificates, and so on and forth. In terms of these facade design and certifications, I have given a bit of a wavy shape just because this is where this facade becomes a bit of a challenge for us. But just to give you a gist of the list, Westmead Hospital, Sydney, 286 Sussex Street, Sydney in the CBD, Adenglassy RACF Retirement Village in Sydney, which is basically in Blue Mountains. New Life Apartments in Darling Harbour, Ultimo, Campbelltown Hospital Car Park, Leppington Station Car Park, Catherine Fields Public School, East Leppington Public School, Wagga Wagga Public School, Warunga Adventist School, Australian National University Canberra, University of Sunshine Coast Brisbane, FV Gardner, Fortitude Value in Brisbane, Gallery House Hamilton in Brisbane, Hotel Indigo in Adelaide, Royal Hobart Hospital in Hobart, Fisherman's Bend School Melbourne, and Rosebud Aquatic Centre in Melbourne. Now that's not a complete list, but at least something from worth mentioning. That's a typical checklist where when we are running multiple projects in one go and to achieve some efficiency, then we look into optimizing our design for various projects in one go. And this is where I have included at least one example that also gives you an idea of when we talk of a facade element, what it could be. So it can be a sunshade, it can be a batten screen, it can be a balustrade, it can be a PMS, which is perforated metal sheet, that can be crash rated, that can be crowd rated, just wind rated. Jali screen is a name adopted by Ambience from their Indian background. And louvers can be acoustic or can be a combination of acoustic and ventilation. elliptical blades. So these are different components which come under the bigger umbrella of what we call as facade. Some fancy pictures of these facade elements. So perforated metal screen. So that's what you can see, that it has got certain perforations where wind can run through. Plus it gives an impression in terms of either openness or different shapes. And some of you might have seen these shapes coming up as giving bit of an impression as you look from a certain distance, or at certain times it can be a dynamic as well. So these perforations can be anywhere between 20 to 80% depending on what pattern you want to adopt. Metal thickness generally can be anywhere between 3 millimeter up, and it can have or cannot have, may not have folds at the ends. It can have a V shape, little bit, uh, but this is where
নীলেমা নিলে তো তাহলে রিসিপ্টটা সারা নিতে পারবা, ওদের নিয়ে তাহলে তুমি বাসায় নিয়ে যাও। মা
डॉक्टर साहब, अगर आप मुझे एडमिन बना दे तो मैं इस नॉइस को कंट्रोल कर लूँ।
ओके,
आप मेरे नाम पे पार्टिसिपेंट में मेरे नाम पे जाके राइट क्लिक करेंगे तो
make him host.
Yep.
Okay,
thank you.
আচ্ছা।
So perforated metal screen, PMS, is the main product from this facade point of view, which acts as a curtain wall and can be used to give very aesthetically pleasing shapes. Then acoustic panel is the next one. There can be some aluminium ceilings perforated, which are sometimes adopted due to certain fire requirements, where within a certain floor, when you have to escape a certain percentage of air in any undesirable event, then these are those type of ceilings that act as a cushion. Then slotted aluminium mesh, you can see this one, metal wall panels, and this is what you can see, that how these perforations they look like in terms of the impression they give. And this where you can see a building envelope. Some shapes can be just like a matchbox, but quite often you might have seen these shapes look aesthetically pleasing as well. Then you can see some sort of these type of screens, this red shaped. That's where the type of what we can say manufacture or fabrication is not like a perforation in the sheet, but still you make it with different colors and in a shape that gives a pleasing impression. These are the louvers. When we call them acoustic louvers, it means that there may be a plant running behind these ones, and you want to control the noise. Plus, at the same time, you also want to have some transmission of air from in out or out in. Plus, you want to cover whatever an ugly looking plant if it is not covered. And this is one of the most cost effective way of putting it in front of it. Then ventilation louvers, elliptical blades, they also give a very good impression in terms of if you want to give it a aesthetic shape. Sunshades, so these are the vertical sunshades where at a certain angle sun is not directly hitting into the occupant and sitting inside, but after a certain angle, then basically the effect starts coming up, but we are protected from the oblique angles. And so these are all those type which basically are covered under the bigger umbrella of what we call as a clad or a facade. That's where you can see some pleasing effect. Project we delivered, I think, three plus years ago in Fortitude Valley in Brisbane, just at the heart of the Fortitude Valley. That's where you can see the shape. These are V-shaped panels, and they can have different colors, and the pattern gives them the impact which looks like really great when you look at from a distance. So the building heading northeast, the color of facade transitions from bronze to silver and eventually becomes the unified palette of silver. So that's where you basically give an impression of how your cosmetics look like. The structure, the main building frame structure obviously is inside, but whatever is a walling panel coming outside, it can be glass, it can be aluminum. Like even if you look at whatever you can see over there, sometimes it's hard to differentiate whether you are watching something made up of aluminum or glass. The way the color scheme and the profiles they work. Another one in Brisbane, Gallery House. You can see the shapes, something like a punching out type of behavior. But these are makeup of those folded panels where you can give these shapes. It has got two buildings, so 16A, 16B, one is 19, one is 20 story, and then we have got these aluminum louvers either over there or at certain openings where you want to have certain protection up to a certain headroom. University of Sunshine Coast, another one in Queensland, where again you can see this project got award won by the builder, the main contract builder. But facade obviously has certain weightage in terms of winning numbers. That's where you can see these are fins, and they are running all the way from a very lower level to a higher level, and their connections obviously are very delicate. Their design criteria is not rocket science, but it's quite involved in terms of looking into different design scenarios and the way they are fabricated, transported, and erected. And obviously there are quality control procedures from design to certification all the way. So that's where you can see different shapes which are emerging out, like something going out, in, and then again having different V shapes, giving a very, very beautiful combination. In Sydney, 25-story Sussex Street, we designed one of their curtain wall all the way from there to there. It was, and the previous one in University of Sunshine Coast was also, and this was, we had got a wind tunnel study conducted. There were the reason was twofold. One is the whistling sound which wind can produce while running through these perforations, and its structural strength or structural stability, because the vibration or the natural frequency is associated with the whistling sound. So that's where we have to see that what natural frequency we can consider where this whistling sound is not that prominent. Otherwise, some buildings, I wouldn't say failed, but have a bad name in terms of their performance. The reason being, when there's a high wind blow, you have a displeasing effect on your ears in terms of the whistling sound due to these facade elements. So acoustic behavior of this one is another science. We are not directly involved in that one. There are other consultants, but at places we have to work hand in hand. And this is one good model. The previous project of University of Sunshine Coast was also another good project where we had to work hand in hand for reviewing the wind tunnel studies and their outcomes. Fisherman's Bend in Victoria. It has got what we call as a rope facade, where this type of V-shape members, they are fastened onto a rope. And this is where you can see this rope is running all the way from this point to this point. So whatever you can see there is a rope. And these are the panels on members which are hung between this point and this point. And then this rope is connected at the top and bottom by some anchor. And in between is just like an eyelet type of passage for the rope facade, or the rope to stay aligned. Now I'll run a video which is not for this project. It is a similar project which I visited just to get some idea of the displacements and why I'm showing it, so that you can see that sometime we have to then conduct dynamic models, because the displacements can't be verified by generic rules of or empirical relationships, that whether displacements or deflections under certain conditions are within limits or not. We have to make decisions based on their natural frequency. So here you can see, this is the sort of deflection coming up. And there's no heavy wind blowing. I'm only pressing palm of my hand and tapping it quite frequently. And you can see that the deflection or the sway was quite significant. When I say significant, it was in the order of 150 to 200 millimeters. And this is where, when you have to look at your nominal criterias of either span on 100 or span on 500, whatever way it works, these are not where we find the justifying solutions. Strength checks are there, but from a performance point of view, from serviceability point of view, then we have to look into other ways to justify. But that's another interesting project which we have delivered, and it is now in construction phase in Melbourne. Next one is also another great project. We have almost 90% finished, Leppington Car Park in the southwest of Sydney, where we have got this jolly screen over there and this Walla net. And this is the type of cloud which will be the end product. Now, since we have almost just finished the design, it has gone into the fabrication stage, but I think maybe down the track, when there's another opportunity, I may be able to share some really great photos of this jolly cloud, which gives a very, very dynamic effect. And for us to validate this type of facade, we physically prepare that model in the office to look into the torsional behavior, and we ran some dynamic model to see that at what natural frequency the torsion appears. So that's where it's quite involved in terms of identifying. They look like small elements. The widths are small. The swag bars, how do they work, and how this whole system work. Pretty delicate, I would say. A sample calculation of some wind loads, which one of the primary criteria. Almost every single facade runs through this wind calculations, And those who are involved in working out the numbers for wind forces, they know 1170.2 in terms of its application for height, for zone, for category, as well as location, as well as localized behavior. So many parameters are there. And then for quality control checking point of view, so you can see that prepared by JV, one of our design engineers in the office, one of our senior engineers, Vinay, checked it, I have approved it. And we have got all these annotations in terms of where are we getting these numbers. Then these calculations go to a review engineer by the main contractor. And then a dialogue starts wherever the discussions are needed to be on the same page in terms of their thoughts and our approach. And once it is signed off, then it goes for fabrication. And from there, it goes into installation. And once it goes into installation, we go to the site once again to see that whatever has been installed is as per the design advices. So this is where quite involved process, but those who have a passion of structural engineering, they would really love in terms of what is done. A very hot topic for last few years, and this is where the insurance premiums have gone really skyrocket. But they have now introduced a clause that whether those who are involved in facade design but using a non-combustible type of cladding, then their insurance basically comes down to a reasonable figure. Otherwise, it was way over budget in terms of the way it has gone up. So currently, the material we are using, which is basically procured and produced by our prime client, principal client, Ambience, that is certified to all these standards, where it has got a certain wind load capacity, it has got a certain fire retardant capacity, and then these certificates are required for the signing authority at the end of the line, but they start asking these questions from the start. So we have to be careful in terms of whatever fire requirements for these ones. And this is where I have a brief overview of Grenfell Tower failure, which was primarily due to fire in the facade. So I will touch base it towards the end. This is where crowd rated loading. It means that whatever area we are talking where these facades are to be installed, whether stairs, landings, external balconies, edge of roofs, there are certain procedures we have to follow, certain loadings we have to consider, and these criteria change from location to location, as well as the requirement where they are to be adopted. Similarly, some facade, particularly in the parking areas, above grade parking areas, they have to be crash rated, so that if by accident either a car in the parking area may have hit the accelerator instead of the brake, either in the backward or forward, and hit the facade, then these facades have to be crash rated so that the car should not fall onto the street. It does happen in some cases. I'm not sure whether in all those cases the failure was because of the fact that the screen was not crash rated, but to the level of projects we have been involved, this is not something we can miss if it is a parking area above grade. And for different whether it's a light traffic or it's a medium traffic, we have different forces, and then you can see a very high magnitude of force if it is on a downward travel on a ramp. But these are the guidelines which are available in Australian standards. My purpose was just to give you a brief that there are fancy pictures, but these fancy pictures have a lot of science behind it. and very careful and thorough checking of the connections or the materials or the performance of these elements. That's a typical example of a design sheet where partly you can see a finite element model has been shown, some calculations where we are trying to put some numbers to compare from actions versus the strength. And the purpose is not to discuss these calculations at this stage, just to give you an overview of how and how the procedure basically goes from A to Z. That's a serviceability check where we are looking at some sort of a deflection in a static way for certain, like this V shape. Then this is where you're fixing into the concrete, embedded concrete. So we are doing some strength check of that panel which is embedded into the concrete, and there is a pull-out strength to be achieved. Plus this is where, for example, some direct tension forces are coming up because it is an outrigger where your forces are concentrated, and then you have to design this your element based on these forces, like a corbel action or a plate behavior where you will have a support there, and then this plate is a two span continuous, or there will be a tension and a shear combination forces coming up. So all these checks, they are necessary before we come into the conclusion that yes, it is okay. So that covers partly that component where whatever we have done to date. Then I go to my other presentation, but it will be a brief overview. I am involved in supervising some international students, and one of the universities is Northumbria University in UK. So in last semester, they were given a project of a case study for this Grenfell Tower in UK. So this presentation is basically prepared by them, supervised by me as an external supervisor, plus internally they have their own internal supervisor as well. But with an acknowledgement to those students who prepared it, I'm just giving you a brief idea of some findings of the reason of the failure of this tower. So this happened in Wednesday, 14th of June 2017, when a fire broke out at level 16. And there is an introduction that whoever basically owns this tower. So in terms of one of the reasons where we can see the external walls of the building shall adequately resist the spread of fire over the walls and from one building to another, having regard to the height, use, and position of the building. Now that's the regulation which is considered as a legislation. And this is where you can see these reference of the documents from British standards or Euro codes. The question is that what has been followed and how much it was followed. Insulation must have a limited combustibility, and there are class 0 tests, which is surface spread of flame must be less than 165 millimeter, 5 propagation burn chamber must be greater than 20 minutes. And what has been identified, there have been loophole in tests, and its limited combustibility test was also failed, where that actually triggered a lot of eyebrows. Yep. So going back to this some sort of fact finding. So choice of cladding and insulation, I think that has possibly zero marks. There was more emphasis on aesthetics. So we are talking on Grenfell Tower. And then very serious issue was that there was a real lack of fire safety consultants and fire engineers on the project team. And another dilemma was that the architect studio, they have no experience in cladding for high-rise buildings. And cladding subcontractor has no employee with completed qualifications in facade engineering. So this is where, as I said, that what is behind the scene stories, but once they come to the surface and they are shown in these dot points, obviously it's really sad to see that we have opportunities to make things work, to deliver a better product and engage right consultants, but sometimes it doesn't happen, and then it ends up in loss of so many human lives, as well as loss of reputation, loss of property, and loss of good name. So how the fire spread to the cladding system, you can see an arrow over there. So that is where the main research, obviously it was not done by my students, but they took it from the sources they actually reviewed, that this is where the potential fire spread route through window framing materials and into the cladding cavity. And the problem, as far as I'm aware of, is that once the clad wall, which has very low combustibility, very high combustibility and very low resistivity, once it's basically start burning, then it was a continuous wall from top to bottom, and it was just spreading as if it has got the fuel, and that fuel is now doing its job in terms of making it work for all floors. Similarly, this is where you can see some sort of cross sections where we can see EPDM weatherproof membrane visible from interior, original window frame location, and reduction of window size and movement of window outwards. So that's where these are the possible sources where, at least from one level to the other, the fire has been entering from outside to inside. And similarly, there is a cavity behind window jamb, and another dilemma is that exposed combustible Celotex insulation bearing logo. So there was no quality control check on what products were used and what procedures were adopted, and that ended up, that facade failure has ended up failure of the whole building. So cavity barriers missing or installed incorrectly in windows, not continuous cladding rails breached every 1100 millimeter, because you are not expected to have their continuity after a certain length, but that was breached. And there were like the problem with the gaps, the fire stops not fitted properly. Obviously, all these things have come up on surface, and most of these would have basically saved to a certain significance. And on top of this one, if there have been sprinklers, they would have definitely saved the tower, as long as the sprinklers were working at the right time. But these are those statements which are supporting that what could have been done. But now the regulations have gone to that level where I think things are not only within UK, but all around the world. They are very, very stringent. But still, we have seen other type of failures happening in the industry. And that's where whatever best can be done in terms of either as a design engineer or as a certifying engineer or as a contractor or a supplier, as long as we have a due diligence criteria, as long as we have ethical criteria, as long as we know what we are doing, I think we'll be saving ourselves as well as others. So rest of the discussion is basically what the students prepared for their follow-up presentation, but the case history was for Grenfell Tower, which again I acknowledge to the students of Northumbria University, to whom I supervised in last semester, last year. So this is where I stand at this stage, and I pass it on to Jelani Saab to open the forum for discussion. If our fellow friends, they want to ask some questions on the discussion or the presentation I have delivered.
Thank you, Dr. Saab. First of all, I want to thank you for this presentation and continued support to the group. And secondly, group member, if you have any question, please feel free to ask. Anybody has any question?
Hello, I have a question. In fact, 3 questions, not 1 question. What makes balustrade different than the batten?
Can you introduce yourself briefly and then ask the question?
Yeah, my name is Masood. I'm civil engineer. I have like 8 years of experience in high-rise towers in Dubai, and now currently working at a refinery in North Queensland as a civil engineer.
Mm-hmm.
So yeah, this is my introduction. So my question is, what makes balustrade and battens different? Is it the height, or it's the whole structure is different from each other's, or it's the material?
Generally, I think balustrades are more of acting as a cantilever, and they are not from floor to floor. And battens are running floor to floor with a bit of a connection on both edges, plus whether they are crowd rated, it is unlikely, but balustrades are, in most cases, they are crowd rated because they have a purpose of providing an edge protection in terms of what level of crowd we're expecting there.
Okay, thank you. My second question would be like combustible cladding materials. As you mentioned that a couple of years ago, Queensland Fire and Emergency Services, they asked every property owners to have an audit of the combustible cladding materials.
Yeah.
And if it falls within combustible material or no, so they have to take some actions. So what it has a result on like manufacturing, whether we have changed the production material of the claddings, or it's like more going towards metallic and aluminium, and because aluminium claddings actually they were having more like fire incidents, ACP panels, which I'm referring to ACP panels, but whether they are going more towards metallic and just aluminum alone, like without having like any of the silica materials and those things. So what has been the impact on the industry, whether material has changed or what has changed, like in fact?
Yeah, it has a significant effect. In terms of aluminium, if aluminium has got a sandwich panel inside, which is combustible, then we can call it combustible. Otherwise, the tests we have witnessed or the reports we have received of the aluminium, whether it is architectural grade or structural grade, we obviously look at those parameters which need to comply with the BCA standards. And I'm not aware of aluminium directly where that metal has combustibility. But if it is having a sandwich behavior with other materials, foam type materials, then yes, it has. Not only Queensland, but I think in New South Wales as well as other states, they have followed, or particularly in Victoria as well, they have followed the suite in terms of doing audit for these facade materials. Now, what measures they have taken, I have limited knowledge, but regulations are in place, particularly for those which have been identified at risk and what treatment they are doing. It is case by case, but I'm aware of the fact that yes, the treatments are in place, uh, and the compliance procedure is working, particularly for the new built, definitely, but those already existing, there's always a catch, how quickly and how easily you can do. Like, for example, we do some forensic studies for buildings which were built in, let's say, 1970s or 1980s. They are double brick, having a concrete slab, but having some sort of areas where they do not comply in terms of compartmentation or other issues, or maybe sometime in terms of the cover requirement of the concrete slab. But you can only do treatments to make it compliance. Otherwise, whatever is at high risk, they definitely have been either changed or in the process of getting changed. Now, I honestly speaking have limited knowledge on this one, but yes, that opens up a discussion where maybe down the track, what further information is identified on my end, I'm happy to share.
Thank you. Thank you. And my last question will be about the louvers. You mentioned acoustic louvers, and even I have installed in my construction site, but I didn't get a chance to have a look at complete profile actually. So what makes it like acoustic? Because it has already slots and openings through it. So like how it works, the phenomena.
Generally, our role is in terms of its structural integrity and strength, but the way I am aware of these louvers is that they block the transmission of sound, and they have the type of material which has the capacity to absorb. Now, this is very similar to those type of acoustic walls which you place, let's say, on the sides of a motorway, and they act as an acoustic wall where they dampen the effect of the noise. But how do they do it? Definitely there is some rationale, some empirical relationships, or some science behind it. So it is a combination of the material plus the type, the way they put it in an angle where most of the sound or most of the noise is dissipated. Now, how is it done? Again, I think we need to talk to an acoustic engineer.
No worries. Thank you. No, that's fine. That's fine. Thank you.
I have visited quite a few spaces of sites where it has been installed, and to the best of my understanding, yes, they are working good. That they do control the mechanical sound, whether it is from air conditioning plant or anything else. Where in the absence of these louvers, there's definitely a high noise coming out.
Yeah, no, thank you. Thanks a lot.
Yeah, any other question, please? So look like we don't have a question. So Dr. Saab, just to understand, what is the ratio in this process is the quality or manufactured property of the facade elements, the structural design, and the constructability. So either there's a different people responsible for all three items, or there's a one person like you, designer, who's involved, and how they weigh all these three components.
Typically, I think industry is more inclined towards a DNC type of package, where the installer is the supplier, as well as has got engineer under his umbrella to prepare a design for him. But the design, whatever comes out of his engineer, is cross-checked and peer-reviewed by the main contractor or the lead engineer of the overall project. So there are checks and balances, but due to the type of what we can say, the nature of the job, typically it is DNC, where in some places, even architects are also part of the team, or one single team where architect, supplier, installer, and the engineer, they are working under one umbrella. They are not acting as a different team. But that is not the case everywhere. I'm aware of a few installers and suppliers who have like big names and they have got good reputation, but they give you a complete package. But you can see that okay, what are you after? Yes, we want this thing. Okay, you will get it. And then that's where they get it from architectural concept towards engineering design, towards identifying the material, towards supply of the material, then fabrication, installation, and certification. They all provide you under from that one same company.
Thank you, Jiva. Yeah, it clarified the answer. Okay, any other question? Otherwise, we wind up the session. Okay, thank you, Hassan Bhai.
Assalamu alaikum, sir. Sir, my name is Hassan Javed. Sorry, I'm in the train, so if the signals cuts out, I will think of another good question. But first of all, thank you very much, Azhar Sahab, for giving us a very thorough and in-depth review of all those beautiful facades done by you. My question is basically related to council. As these facades all sometimes require a lot of maintenance, do we really need to get a council approval? Because some old buildings, they don't have any access from the roof, or they don't have any hold point so that the roof access, so any rigger can lift up. So some has advised, some councillors have advised that they need an approval, specific approval, and some council says they don't need an approval, you just use a cherry picker with traffic consultants. So what are your comments on that?
Good question. Now, if we are talking of CBD type councils like Sydney or whatever controls within Brisbane, because Brisbane is a very big council, and whatever is in the CBD for Melbourne, yes, we are definitely talking of very rigorous procedures. But what I have noted in most cases is that it is a part of the package for development approval. And once the development approval has been achieved, where obviously the color, the look, the aesthetics, that is all measured from DA approval point of view. Once council has given the go ahead, after that, I doubt that council has any further control in terms of its installation or the maintenance. Maintenance generally comes up either with the body corporate management or strata, which generally is the case of multiple owners of a building. Otherwise, if it's a parking area, let's say owned by either a railway authority or a council, then they may have their own maintenance plans for this one. But typically, yes, it is an area where not much focus is given down the track. At the time of installation and fabrication, yes, it depends on how much careful is the architect in terms of the selection or the choice of type of clad, and how much careful is the engineer and the fabricator. Once they have done their job, there are insurances, or there are guarantees, there are warranties from the fabricator, and given these warranties are in place and they are coming back for defect liability or covering their warranty, there's no other way we can say that any further rigorous maintenance plan is in place.
Thank you very much, sir, for the answer. I think it covers most of the aspects. Considering the decency type of the project, I do believe you are absolutely right in this aspect. But I just want to add one thing. Basically, I was involved in one of the projects with council, and they deferred it to the design engineer to advise the right way to how to use the support or maintenance system. So when you are designing facade, is there any chance you have advised any hooks on the roof or anything as a project manager we need to look into, especially when we are doing a facade project?
These are driven by the lead architect. These are proprietary.
All good, sir.
Yeah, these are proprietary products, but driven by the lead architect at the time of DA submissions. And if the council is referring it back to the engineer, it could be the case. I'm not saying that that can't be the case, but in most cases, these are driven by the lead architect, where yes, there could have been an early advice, but these cases, in terms of their maintenance point of view, not has come to our dish to look after. Maybe our principal contractor have their own arrangements in terms of, as I said, proprietary product. They have adopted systems which they generally use, but not to our knowledge, or not for us to work on day-to-day basis.
Thank you very much, sir. Thank you very much for the answers. And again, once again, thank you very much for the word of wisdom, especially sharing us another research. Now we know that mistakes are not only Australian, they are also British.
Yes.
Thank you very much, sir.
You're welcome.
Thank you, everybody. Is there any other question we have? Okay, thank you. We can wind up the session. Dr. Saab, thank you very much.
Thanks.
It was a great pleasure to have you here.
Yep.
And thank you, everybody who participated. Thank you very much.
Thank you. Bye.